Hey, so we're given 4 points, A, B, C, D, and we're asked to do a series of questions here, starting out with finding the vectors A, B, and B, C. So part A, the vector A to B. A to B will be 1 to 0, that's down 1, 2 to minus 1, that's down 3, and 1 to 2, that's up 1. And then B to C will be 0 to 1 is 1, negative 1 to 0 is 1, and 2 to 2 is 0. Part B says to calculate AB cross BC. So that's cross product, AB cross BC. So IJK, and we'll plug in AB first, so that's minus 1, minus 3, 1, and 1, 1, 0. So be very careful when you're doing these cross products. I see mistakes all the time. So these vertical lines means the determinant, so I'm taking the determinant of this 3 by 3 matrix in essence. So what I'll do, I'll just write it like this. So I'll start here, so that's 0, minus 1, which is minus 1. And then I do 1, so I reverse it now, take these outside ones. 1 minus 0 is 1, and then the last negative 1 minus negative 3. So negative 1 plus 3 is 2. So let me do that again real quick. So 0 minus 1, 1 minus 0, negative 1 plus 3. Okay, I think that's right. So now, part C says find the equation of the plane that contains the points A, B, C, and so what I have here is I have negative 1x plus 1y plus 2z equals d. This vector here is perpendicular to the plane, and that's what we found here, perpendicular. So now I just need one point. I'll take point A, 1, 2, 1. Actually, I'll take point C. How about that? 1, 0, 2, because it's got a 0. So minus 1 plus 0 plus 4 equals D. So then we get x minus x plus y plus 2z equals 3. When I simplify that, we get 3 equals D. So that's part C. Part D says find the line containing D and is perpendicular to the plane. So part D. So containing the point, so we're going to get R equals the point D plus T and is perpendicular to the plane. So that means I can take this vector, because this vector is perpendicular to the plane, this one that we found right here, negative 1, 1, 2. So negative 1, 1, 2, and the point D is 2, negative 1, negative 6. 2, negative 1, negative 6. And that's it. This is the direction that's perpendicular to the plane, and that's point D. So the last part is to find the shortest distance. So what I want to do is I want to find, basically what I have here is my plane, and I've got this line now, and here's point D. So I want to find the shortest distance, but first I need to find at what value of t on this line does it intersect the plane. So what I need to do is I need to find the intersection of this line and the plane that I created in part C. So negative, this is the x values here. These represent all the values of x on the line. Here's x on the plane, so I'm going to plug in this piece right into x. So that's 2 minus t. Do the same for y. Negative 1 plus t. Do the same for z. Oops, don't need that actually. Okay, so that's 2 and z, negative 6 plus 2t equals 3. So now we just have to solve for t, and that will tell me the value of t on the line that happened at. So negative 2 plus t minus 1 plus t minus 12 plus 4t equals 3. So combine like terms. How many t's do we have? We've got 1, 2, 6, 6t. And then the regular numbers here, we've got minus 2, minus 3, minus 15. So minus 15 equals 3. So then 6t equals 18. Should have written a 6. And therefore t equals 3. Alright, so to find this distance, I've got two options. I can either find this point here by plugging t into this equation here and finding the point, and then find the do the distance formula to find the difference of the points, or I can just plug in 3, because t is 0, I've got this point. T is 3, I'll get the other point. So all I need to do is plug in 3 right here. So that's negative 3, 3, and 6. And define that length. So negative 3 squared is, so just take 3 squared plus 3 squared and 6 plus 6 squared. So therefore the distance is, this is 9, 18 plus 36 root 54. And we're done.